Good morning, General Chemistry. How are you guys today? I hope everything is going well. I hope everybody's staying safe and healthy and not affected too much by this craziness. If you are, hopefully you're watching the videos in order. They are in order under Blackboard. So I think if you go to the YouTube channel, there's a lot of them. So go to Blackboard. We're under Unit 3 for you guys. And if you have watched in order, hopefully you saw the first series of mole videos where we really took our time and we kind of went through and we really just defined everything and spelled everything out. And in this video, I want to take what we learned in the last video and actually just apply it. So this video, hit pause for a second, grab your periodic table, grab your calculator, grab your unit conversions table that we used on the first test. You're going to need all three of these things, and we're just going to do math in this video. So I put together a nice little kind of summary for what we've already done in the mole. And one of the things we kind of mentioned was, all right, it's getting real now. When we picture this molecular formula, this literally tells us a story. This tells us so much about whatever that substance is. We learned in Unit 2 how we can take that and draw it. We could draw the structure for that using our bonding rules. We also learned that we could add shape to that. We could do all kinds of things in Unit 2. We learned that those atoms follow those bonding rules and they fit together in a fixed ratio. And then now in Unit 3, we're taking that same formula and we are adding a ton of math to it. So our story for that formula just got bigger. So now after this video, I want you to picture every time you see a formula, holy crap, there's an awful lot of math here. This is literally our own unit conversion, all just for that substance. So our methylamine in this case, that is telling us everything we need to know to do calculations with this substance. So what did we do in our last video set? I wanted to kind of help you with your cheat sheet, and I wanted to kind of summarize everything if we could. The first thing we did was take the formula and assign, just in general, let's picture what would be in 1 mole. And remember, why do we give a crap about the mole? Well, our mole is how we're going to do math with this formula. Our mole is our go-between. It is our way to literally count atoms. So super shortcut on that. If you ever read a question and it's asking you how many atoms, how many molecules, how many of something, you're going to have to use Avogadro's number in there. That count is coming from Avogadro's number. And then if you're asked how to weigh something or a mass of something or how much, that is then connected to our periodic table and our atomic weights and our molecular weights. So when we picture CH5N, holy crap, we get all of this information. We literally have our mole ratio that's telling us how many of each one that we have. We've got 1 carbon, 5 hydrogens, and 1 nitrogen. We're connecting that to our atomic weights. So 1 carbon is worth 12 grams. So 1 hydrogen is 1 gram and 1 nitrogen is 14. And then how do we picture all of those together? Together, you can literally add those up. That is a sum, and that is our molecular weight for that compound. So what did we learn from that? 1 mole of our methylamine has 1 gram of carbon, 1 mole of carbon, 5 moles of hydrogen, and 1 mole of nitrogen. And that whole thing weighs 31.58 grams. Okay, I love it. And then how do we count all of that? Well, in that 1 mole of carbon, we've got 6.022 times 10 to the 23rd atoms of carbon. Now in hydrogen, we didn't have 1 mole, we have 5. So we've got 5 times Avogadro's number. We also need to remember when we add this up, we've got 5 times that atomic weight. And then in our nitrogen, we've got 1 mole of nitrogen, 6.022 times 10 to the 23rd atoms of nitrogen. And then here's the tricky part. When we look at that total, we have Avogadro's number of them all stuck together as molecules. So that one's a little bit trippy. How can you have that? You have to think about what your elementary entity is. And in our elementary entity, we're going to picture both atoms and molecules. Why? Because our next series of videos, we're about to take our substances and do reactions. And so we're going to take all of those bonds we learned in Unit 2, and we're going to break them. And then we're going to rearrange and use everything that's in there. And then we went on in our last video on moles to go ahead and calculate some percentages. We called this a mass percent. This is actually leading us into empirical formulas. That's where that comes from. We're taking our total molecular weight and we're figuring out how much of that is carbon, hydrogen, and nitrogen. These percentages we can use in problems. So we can sometimes do some of our problems in 2 different ways. We can use percentages or not. But I hope this little first page table is helpful to you. I hope it's helpful on your cheat sheet. We're going to take almost every number on here and we're going to use it in a whole series of problems. So I'm posting this PDF so you can have this PDF next to you while you're watching the video. And then what I've done after this is literally just give us a whole series of problems that are very similar to your homework. And let's just work our way through each problem and let's solve whatever we can in each one of those problems. And if it's okay with you, I'm going to take a second and erase some of my highlighting. That way, when we need numbers for our problems, I can come up and highlight, okay, where in the Sam heck did that number come from? And let's see if we can figure out how to use it and how to use those. So we've got lots of concepts in here, lots of numbers to use. So we'll kind of point out for the first couple problems where all of that is coming from. And then we may pick up the pace just a little bit. All right, let's scroll down and see what our first question is. All right, please calculate the number of moles in a 12.5 gram sample of that methylamine. Okay, done. I'm going to figure out that I'm calculating moles and I'm given grams. All of these problems are going to be set up just like a unit conversion. This is awesome. So I'm going to give you my super secret technique. What I like to do is start with what I'm given. Just like Unit 1 when we did our unit conversions, it's exactly the same thing. The only difference is our units are going to come from up here. Our numbers, our unit conversion. So we're given 12.5 grams of that CH5N. And then we're asked to calculate moles. So let's set it up just like Unit 1. What we want, moles. What we have, grams. All right, so now this is the difference. You can't grab that unit conversion from a table. This one comes from up here. How do we connect a mole of our CH5N to grams? Right there, molecular weight. This is your unit conversion between a mole and a mass and grams. Notice the question asked you or gave you grams. It didn't ask you for a count. It gave you a mass. So let's put that number in. That is our unit conversion now. That 31.058. Let's see if I can remember that. 31.058. That is our molecular weight. That's where that came from. In every 1 mole. That is our unit conversion. So let's grab our calculators real quick. Let's plug that in and see what we get. And then we'll talk Sig Figs. All right, I am going to give us the whole calculator answer. I won't always do this, but just for this first couple of problems, this is what I'm getting. Okay, holy cow. And remember, that is CH5N stuck together. Those are not broken apart right now. Those are stuck together. All right, so what do we do for Sig Figs? Well, the only number that we're given in 3 significant figures, so our answer is going to end up in 3 significant figures. So I'm going to slim that down like that. All right, let's put a heart around that because that is done. See, we can literally take this whole story up here and we've just created our own unit conversion table. That's all we did. So the secret to our moles is just figuring out, holy crap, which numbers do we put in when? All right, let's do another problem. Awesome. All right, let's calculate the number of molecules in that 12.5 gram sample. All right, we can do this one two ways. Let's go look for molecules and grams and see how they're connected on our little table. All right, I see molecules right here, and that's our Avogadro's number. But there is no number that is going directly between these. There is no way to do that. You literally have to go through a mole. We have to go here first. So we're going to have to go from grams to moles to molecules. Let's write that out. We're going to have to go from grams to moles to molecules. We don't have this direct. We have to put moles in the middle of almost all of these problems. Moles go in the middle. Okay, so we've already calculated moles in the last problem, so let's take that number. That was our last problem. Let's scroll up a little bit. We just went from our 12.5 grams right here to our 0.402 moles. So I'm just going to take that number. And then now we're going to convert to molecules. All right, here's a huge signal. Molecules is asking us to count something. So what number is it that we're going to need to put in there? Well, if we scroll up, we saw that the number that we need right here is Avogadro's number. So let's put that in our unit conversion. We're going to have 6.022 times 10 to the 23rd. Ooh, I ran out of space. Not good planning on my part. All right, let's calculate that. Grab your calculator. Let's see how many we have. All right, I am getting, let's write out, oh, what did I do? I hope I didn't erase everything. There we go. All right, I am getting 2.420844 times 10 to the 23rd molecules of CH5N. All right, we could slim that down again to 3 Sig Figs. So I'm going to then slim that down to that. Molecules CH5N. All right, let's put a little heart around that. That is done. Okay. Awesome. So again, we're just doing a unit conversion. The only difference is our unit conversion table is up here. It's what we created on our last set of videos. Let's scroll down and see what our next problem. If you get the vibe yet, we are getting sassy each time we scroll down. All right, let's check out this one. We have got 12.5, this time pounds of samples, and we're out of the sample, and we're asked to calculate molecules. Okay, well, son of a motherless goat, isn't that pointless? Didn't we just do that? We just started with 12.5, but it was grams. Okay. So the difference then is our unit. Our unit is now in pounds instead of grams. So we need to string together a couple steps in this one. Anywhere up here on all of our masses, what was the unit for every single mass? It was grams, always. So the only way to use this whole relationship and go between moles and molecules, your masses have to be in grams. So how do you make Gen Chem 1 problems sassy? You give a mass that's not in grams. But we know how to calculate that. We did that on our first unit. Let's take that 12.5 pounds, and let's convert it to grams. And then once we're in grams, now watch this. I'm going to string it together because then we know what to do after that. Because after grams, we need moles. That's in the middle. We just calculated that part. And then our final question is molecules. So now we can fill in our numbers. We're letting our units tell us, okay, this is what we're starting with. This is what we want. Alexa, stop. Sorry, I had a lunch timer. So if this is what we're starting with and this is what we want, it doesn't matter if we've got a couple steps in between as long as our units are canceling. And we're still following our process. We're going from a mass to moles to a count to molecules. We still have moles in the middle. Look, they're right there. Moles are still in the middle. Now we can simply fill in our numbers. All right, I'm going to grab my unit conversions table, and I notice 1 pound is 453.592 grams. And then what do I put in next? My grams to moles. We already did that. Wasn't that our molecular weight? Wasn't that, let's scroll up just a little bit, wasn't that the 31.058? It was 31.058. And then molecules to moles, what was that number? Avogadro's number. All right, bust out your calculator. Let's see what we get from this one. I'm going to bust out my calculator and let's see. Okay, remember to kind of string them together in order. Don't forget your exponents. I just got 1.09936692 times 10 to the 26th. Now there's a reason I strung all three of these together. You can stop in between if you want, but your rounding will be different. I got this whole number without rounding until the end. If you stop in between each one of these steps, you're going to have a slightly different number because it's a little bit better math-wise to round at the very end. So I'm going to round to my 3 Sig Figs, and my answer then is molecules. Okay, awesome. All right, let's get a little bit sassy. So hang on a second. I just want to sparkle pen this one. How do you make Gen Chem hard? You use your unit conversions. So what are you going to need on the next test? Unit conversions table. We're creating our own, but we still need mass unit conversions. Let's write that out. Okay, you still need that unit conversion table. Now we're getting just a little bit sassy again. Look at this one. This is on the homework. Total number of atoms in a gram sample of CH5N. Okay. Let me pause